thinking questions. Good thinking questions. So we're going to talk about how to set up using pictures. That's really what a lot of these are going to be, using a picture, because that's how my brain works. I need a picture. Okay. So this first one says, use the visual shown as a starting point and describe how you can use a diagram to show that a squared minus b squared is the same thing as a plus b times a minus b. So here's what I want you to think about. First of all, this is like a squared. That's like the area of the large square. That's what I want you to think about that as. A times a, that's just going to give me the area of the large square. Does everybody see that? Travis, does that make sense? Okay. And when I say minus b squared, what am I subtracting from it? Well, I'm subtracting the area of the small square. So b squared is the area of the small square. So this is no different than the question that says, find the area of the shaded region. We have done that so many times. You have a rectangle that's gray or green or something with a white rectangle in the middle of it, right? This is the same idea, okay? So I want to show that I can take the area of the large square minus the area of the small square, but I want to use a picture to make it make sense for my brain. Like I want to help my brain understand how to factor it this way. So if this measurement is B, this measurement is also B. Do you guys believe that, right? Because it's a square. Okay. So if this whole thing right here, if this whole side right here is A, then this little piece here can be represented by A minus B, because the whole length minus the little piece that I took out of the top is going to give me A minus B. Is that true for the top? We're going to talk about that for the top. Yes, it is true for the top, but we're going to focus on, do you guys remember finding area of composite shapes? When I say finding the area of a composite shape, do you remember what that was? That was when you would take a weird looking shape and break it up into two pieces, right? So we're going to think about finding the area of this, okay? So now let's talk about this top block. This top block. Well, what if I think about taking this piece, which is B, and this piece, which is B, right? And if I move it over here, I'm just going to pick this whole block up. So I'm going to erase this and I'm going to actually color this in. I'm going to pick this whole block up right here and I'm actually going to move it. Okay. Are you guys watching what I'm doing? So this first box, the first one, the area of this shape, well, the area of this shape is A times, we said this was A minus B, right? And then what is the area of this shape? What is this measurement now? Isn't this now A plus B, right? So this has a width of B, and this is width of A plus B. So I'm going to erase all of this, and I just want to, I'm not sure if I'm making this easier for you or harder for you. If you think about this shape, if you take this piece plus this piece by moving this over, are you not going to get the same area as if you'd taken A squared minus B squared? Yes or no? I feel like I'm confusing you on this drawing. Okay, so here's the way I want you to think about this. We found the area of the first one, which was A times A minus B, plus the area of the second one, which is really B times A minus B. This is B times a minus b. When we do this whole little distributing thing, what is a times a? And what is a times a negative b? Negative ab. And what is b times a? It's a positive b, and we're going to put the a first. So a positive ab, and b times negative b is negative b squared. What happens right here? What happens to those two things? They cancel out. They cancel out. So that is why we're able to factor it using the a plus b times the a minus b. That is why that works. Think of it as a picture, okay? So number 2 is just like, I think it was number 7 in our journal. If you look at your journal, we have a 4th degree polynomial. And so it's still a perfect square. As long as our exponent is even, it's still going to give me a perfect square. So what happens when I try to factor this? So let's think about this. How am I going to factor this using the difference of two perfect squares? The difference of two perfect squares. What is the square root of 16? 4. And what is the square root of x to the 4th? X squared. Yes, ma'am. So I'm going to rewrite that, 4x squared. Then I have to figure out the square root of y to the 4th. What is the square root of y to the 4th? What number do I multiply by itself to get y to the 4th? Y squared. So we're going to put a y squared at the end of that, and we're going to join them with a what? A plus and a minus. So I have 4x squared plus y squared. And I have 4x squared minus y squared. So look at example 7 from your journal. I think it was 7. No, it's example. It was example 3 from your journal. Look at example 3 from your journal. What did we discover we could do? Look at example number 3. Look at your journal, example number 3. What do you see, Brian, when you look at example number 3? What did we do when we had something to the power of 4 when we factored that? What happened? Do you guys look at that factor, that binomial that I put in a little red bubble? What can I do with that? I can't divide it by 2. I can't divide it by 2. What kind of problem is that? Yeah, you can square root it. This is also the difference of two squares, right? So I can keep factoring. This can continue to be factored. So I have the square root of 4x squared is what? What is the square root of 4 and the square root of x squared? 2x. 2x, 2x. What is the square root of y squared? Y. What do I need to join those with? Plus and a minus. And this just comes straight down because this cannot be factored anymore. Why can this not be factored anymore, Amalia? You've already answered this once for me today. Why can't we factor that anymore? Because it's the sum of two squares. Good job. Because it's the sum of two squares. Okay. We're going to do 2 more. We're going to do 2 more of these, and then we'll get you started on your homework. A rectangle has a width that is twice the length. A rectangle has a width that is twice the length. So I'm going to start by drawing a picture because that's how my brain works. And if this is my length and this is my width, it says that the width is twice the length. So the width is, so maybe I should change the way my drawing is. Let's change it so it works with our brain. I'm going to call this my length and this my width. So my width is twice my length. The width is twice the length. So this is an area. This polynomial represents my area. So it says, what expression is the width of the rectangle? What do we have to do with this if we want to figure out what the width is? Well, we're going to have to write this as a product of two what? What am I putting up there? What do we do with a trinomial? What have we been doing with trinomials? If this is a quadratic trinomial, what are we going to have to do to solve this? Yeah, we're going to have to factor it. Do you see? Was that you, Kimber? Good job, hon. So tell me, we have to factor this. Do you see anything that we can do first? Like the number one rule of factoring is to look for a what? Yeah, look for a greatest common factor, a GCF. Is there a GCF in this? What is it? It could be 2. So remember I said if you're looking for a GCF, let's always start with the smallest term. Start with the smallest term. So I'm going to just list the factors of 18 really fast. Let's see. 1 and 18, 2 and 9, and 3 and 6. Is this and this both divisible by 9? Are either one of 48 or 32 divisible by 9? Nope. So it's not going to be that. Is 48 or 32 divisible by 6? 48 or 32 divisible by 6? 32 is, 48 is, but is 32 divisible by 6? No, it is not. What about dividing by 3? Can we divide 48 and 32? Are they both divisible by 3? Okay, so Uriah, if we can't divide them by 9 or 6 or 3, what is the greatest common factor? 2. That's what we're going to divide by. We're going to take out a 2. So I'm going to move it down to the bottom. Matthew, 18 divided by 2 is what? Good, so I have 9x squared. Thank you, sir. Delilah, 48 divided by 2 is what? That's okay, you're fine. 48 divided by 2. Yes, ma'am, 24x. And Kaden, 32 divided by 2 is 16. What method do you want to use to solve this, Carla? Because A is not 1. What method do you want to use to solve this? We have to keep factoring. What? Say again. We can do slide and divide. I have to multiply, right? This is my slide part. So I have to figure out what two numbers, 9 times 16. Let's see, I think that's 144, right? So x squared plus 24x plus 144. What two numbers multiply to 144 that when I add them, I get 12? So everybody pick up your calculator. Travis, get your calculator. Y equals 144 divided by x. 144 divided by x. You're looking for the two numbers. So then hit second graph. What are they, Jansen? You've got it. 12, yeah. 12 and 12. Good job. 12 and 12. Let's see. So 12 times 12 is 144, and 12 plus 12 is 24. So x plus 12 times x plus 12. So that's our factoring portion. Now we have to do the divide. We multiplied both sides by 9, so we have to divide our factors by 9. Divide both of our factors by 9. Use your calculator. Use your calculator to do that because I want this written as reduced fractions. I want that written as a reduced fraction. So 12 over 9. 12 divided by 9. 12 divided by 9, and then hit the math button. Choose fraction answer. Travis, when you do 12 divided by 9, and then you hit your math button, and it says, Travis, do you want a fraction? I want you to hit yes, yes, enter, enter. What do you get for a fraction? 4/3. So this is like saying x plus 4/3, but we don't factor with fractions. We don't factor with fractions. So what do I do with this x plus 4/3 times x plus 4/3. Caden, what do I do with that? What happens to the denominator? What do I do with them? You don't know? Help him out, Brian. What do I do with the denominator? I can't leave it there. Put it in front of the x. So this factors out to 3x plus 4 times 3x plus 4. Is there a better way to write that? What is it? 2 times the quantity, 3x plus 4, the quantity squared. Yes, ma'am. Okay. Okay, we're going to stop there. We'll finish this up tomorrow. We're going to stop right here.